Good morning, friends. Last we discussed about the damped oscillation and also the forced oscillation. We obtained the differential equation for both oscillation and also pure simple harmonic motion. Right? Okay. Now in damped oscillation, the amplitude of the system, oscillating system, continuously decreases with time. Therefore, the amplitude of damped oscillation is the function of time. Right? Okay. Now, already we discussed about the equation of the kinetic energy, potential energy and total energy. That means mechanical energy for a system which performs the simple harmonic motion. Now, today we are going to derive the equation of the mechanical energy for damped oscillation. Because in damped oscillation, the amplitude is the function of time. While in equation of mechanical energy, half k square, that means the amplitude is present. Therefore, we are interested to derive the equation of mechanical energy for damped oscillation. Therefore, for a damped oscillation, amplitude of oscillation is at any time t, at is equal to a is to minus bt upon 12. bt upon 2. That is the function of m. And mechanical energy of simple harmonic oscillator is E is equal to half k square. Therefore, mechanical energy of damped oscillation, the damped oscillator is E is equal to half k a dash square. Here we substitute the value of a. Therefore, half k a is to minus bt upon 20. Right? And whole square. And whole here is, so is equal to half k is square. E is 2. Here power is 2. So that is the form of, just me. We can add in this form half k is square. E is 2 minus bt upon 2m whole square. If B is equal to 0, now what is the B? Damping coefficient. Damping coefficient is 0. Then E is equal to half k square. Is the kinetic energy, is the mechanical energy of simple harmonic oscillator. Is the mechanical energy of simple harmonic oscillator. In this condition, if damping coefficient is 0. Now, after that, very short question on the board. Question is that write equation of amplitude of forced oscillation and explain resonance Already we discussed in forced oscillation. What is the amplitude of oscillation? A is equal to F0 upon M square into bracket omega square minus omega D square whole bracket square plus omega D square and square bracket is half power. That means now amplitude of forced oscillation A is given as F0 upon square bracket M square omega square minus omega D square whole square plus omega D square into D square bracket over square bracket power is half. Power is, there is a question number 1. Now, what is the F0? F0 is the amplitude of external periodic force. Omega is the natural frequency of oscillation. Omega D, angular frequency of external periodic force, and B is the damping coefficient. Because in forced oscillation, initially the system oscillates with the natural frequency. But due to the resistive force of the medium, the amplitude of this oscillation is going to decrease. To sustain this oscillation, we have to continuously apply the periodic external force. After applying the external periodic force, now the system oscillates with the angular frequency same as the angular frequency of external periodic force. Okay. Now here first case, if omega D into B is very small, then M into omega square minus omega D square. Therefore, neglect omega D into B compared to M into omega square minus omega D square. Therefore, the amplitude of oscillation is A is equal to F0 upon M into omega square minus omega D square. Omega D square. That means if the omega D into B, damping coefficient and angular frequency of the external periodic force, this product is very small compared to this term. Therefore, neglecting this term, so equation 1 is written as this. There is the amplitude of oscillation in this condition. Right? Okay. If here the omega is equal to omega D, if omega is equal to omega D, that means now system is oscillate with the external frequency of external periodic force. Or in other words, the natural frequency of oscillation is equal to the frequency of external periodic force. At that time, the amplitude becomes 0. Then, maximum A is equal to F0 upon 0 is equal to infinity. And amplitude becomes infinite. Now, second case. If omega D into B is greater than M into omega square minus omega D square. In this condition, neglect M into omega square minus omega D square compared to omega D into B. Omega D into B. Then amplitude of oscillations is A is equal to F0 upon omega D into B. Omega D into is the maximum amplitude. Is the maximum amplitude. Such phenomena is known as resonance. Is known as resonance. Therefore, the definition of resonance is the phenomena of increase in amplitude the phenomena of increase in amplitude when external periodic force is close to natural frequency of oscillation is known as resonance. Is known as resonance. So only we have to discuss the 2 points in amplitude of force oscillation. One is the omega d into b is greater than is less than this term. At the time what's happened? Omega d into b term is neglected and amplitude is this. In this case, if the omega is equal to omega d, that means the natural angular frequency is equal to the angular frequency of external periodic force. In this condition, the amplitude becomes the infinite. That means the system is oscillate with the maximum amplitude. That is also the resonance. Now, if the external periodic force, frequency of the external periodic force is much greater than this, omega m into omega square minus omega d square. So in that case, we are neglecting m into omega square minus omega d square compared to omega d to b. Then the amplitude is given by this equation. A is equal to f0 upon omega d into b. So this amplitude is maximum. And as a result, such phenomena occurs as resonance because in this condition, the amplitude of the oscillation becomes the maximum. Now, what is the definition of resonance? The phenomena of increasing amplitude when external periodic force, so the frequency of external periodic force is close to the frequency of oscillation. Frequency of external periodic force is close to natural frequency of oscillation is known as the resonance. Clear this? So here the most of the part of this chapter is completed. Only the example of the resonance are given. Right? So read this yourself only for knowledge. So what is the example of resonance phenomena? Okay, after the completion of the theory, already we discussed some numerical of illustration. Now, today we are going to discuss the illustration number 14.8. Here, what is the question? A 5 kg column is attached to a spring of a spring constant 500 Newton per meter. Now, what are the data are given? Mass of a column, mass of a column, M is given 5 kg. Now spring constant K is given as 500 Newton per meter. 500 Newton per meter. It slides without friction over a horizontal load. The collar is displaced from its equilibrium position by 10 centimeter. Therefore, amplitude of oscillation is given. Amplitude A is given the 10 centimeter. That means the 0.1. So in this situation, we have to calculate the period of oscillation. Actually, what it says there? There is a horizontal load, one collar, that means the one block, metal block, is tied like this way. And there is also connected with a spring. So here it can roll on a horizontal load without friction. Initial position of a collar is x is equal to 0. Now we pull up to the x is equal to 10 centimeter distance and release. So it oscillates about mean position. It oscillates about mean position. In this situation, we have to find out first the period of oscillation. Second, what is the maximum speed? Already we know that for the body performing simple harmonic motion, the maximum speed is at equilibrium position. When it passes through the mean position, so its speed is maximum. And third is, what is the maximum acceleration? Acceleration is maximum at extreme point. That means the end point of oscillation. That means at x is equal to plus or minus a. Already we did the equation of velocity and acceleration, and also we discussed about the maximum value of velocity and acceleration. First, what is the period of oscillation? That is only our understanding, guys. Now the period of oscillation, first A, period of oscillation is T is equal to 2 pi under root of M upon T. M upon T. Already we did this equation for spring. Here collar is tied with a spring. Right? Therefore, periodic time of oscillation of a spring, T is equal to 2 pi under root of M upon T. Now we substitute the value, so it's equal to 2 pi, pi is equal to 3.14, under root of M is 500, M is 580, sorry, and first constant is 500, so pi upon 500. As is simplified, we get the answer is 0.628 second. 0.628 second. Simplify yourself these numerical terms. So we get the periodic time of oscillation is 0.628 second. Yeah? Okay. Now second part B, we are interested to find out the maximum speed. We need to find out the maximum speed. First thing, the velocity of the collar with performing the simple harmonic motion. Velocity of a collar execute simple harmonic motion is, there is the velocity at time t, Vt is equal to minus a omega sine omega t plus phi. Omega t plus. Already we derive this equation. Right? For maximum speed, this term must be minus 1. This term must be minus 1 because the right hand side is minus a omega sine omega t plus phi. Right? Therefore, the sine omega t plus phi is considered as minus 1 because the maximum value of sine function is minus 1 to plus 1. Minus 1 and plus 1. Here we consider the minus 1, therefore V maximum is equal to A into omega. Okay. But we know that A is equal to M omega square. Therefore, omega square is equal to K upon M. Therefore, omega is equal to under root of K upon M. Therefore, A into under root of K upon M. A into under root of K upon M. H is substitute the value. Amplitude is 0.1. Under root of K. K is 500 and M is 5. Therefore, 500 by 5. It means the 0.1 into 10. Right? Therefore, 1 meter per second. That is the maximum speed. Now, third part, maximum acceleration. Maximum acceleration. Now we know that the acceleration of a column. Acceleration of a column at time t is a t is equal to minus omega square xt. For maximum for maximum acceleration, xt is equal to plus or minus a. Xt is equal to plus or minus a. Therefore, a maximum is equal to omega square a. Omega square a is equal to k by m into a. K 500 by 5 into 1 into a 0.1. That is the 10 meter per second square. 10 meter per second square. That is the maximum value of acceleration. So where is the numerical? Only we have to substitute the value in equation. And keep in mind that the k is equal to m omega square. Again, we are interested to find out the time period of oscillation of a column. That means the object is connected with a spring. Therefore, the time period of oscillation t is equal to 2 pi under root of m upon t. Substitute the value 2 pi 3.14 under root of m upon k. M is 5 kg, k is 500. Therefore, 0.628 seconds. Now, velocity, maximum speed of a column. First thing, we know the equation of maximum or the velocity of a column which performs the simple harmonic motion. Vt is equal to, that means the velocity at time t is minus a omega sine omega t plus phi. For maximum speed, this bracket sine function must be get the maximum value, because there is the harmonic function of sine. If the sine becomes the maximum, so speed is maximum. So maximum value of the sine is minus 1. Therefore, V maximum is equal to A into omega. Now, omega is equal to what? We know that the spin force constant K is equal to M omega square. Therefore, omega square is equal to K upon M. Therefore, omega is equal to square root of K upon M. Substitute the value of A, 0.1, square root of K, 500 by pi. So 0.1 into gain, that means the 1 meter per second. Similarly, for maximum acceleration, acceleration of a column at time t is a t is equal to minus omega square x at time t. For maximum acceleration, xt must be extreme point, that means the plus or minus a point. Therefore, a maximum is equal to omega square a. Omega square is equal to k upon m. Therefore, we obtain the 10 meter per second square. Now, the similar numerical wording are same, only the numerical value are changed. Instead of the 5 kg, here we write for 2 kg. For 2 kg. And force constant of the spring is, instead of the 500, we take there is the 800. Remaining terms are same. That means a 2 kg coil is attached to a spring of a spring constant 800 Newton per meter. It slides without friction over a horizontal load. The coil is displaced from its equilibrium position by 10 centimeter and released. Calculate the period of oscillation, the maximum peak and maximum acceleration of a coil. The answer, calculate this numerical yourself, that is for homework, and answer are the period of oscillation is 0.314. 0.314 second. Now, second answer is the velocity is 2 meter per second. 2 meter per second. And acceleration is the 40 meter per second square. Check it. Clear this? So you have to calculate yourself this numerical. On the basis of given numerical, only the numerical values are given. After that, the next is 14.9. What is the length of a simple pendulum which ticks the second? Which ticks the second. Now, time period of a simple pendulum which ticks the second is 2 seconds. Here we have to find out the what is the length of a pendulum. Here periodic time is not given, but the periodic time is 2 seconds. Because the time period of a simple pendulum which takes second is t is equal to 2 seconds. For simple pendulum, time period is t is equal to 2 pi under root of L upon G. L is the length of a pendulum and T is the periodic time. Therefore, making the square, T square is equal to 4 pi square L upon G. We are interested to calculate L. Therefore, L is equal to T square G upon 4 pi square. What is the value of T? That is the 2. 2 square G, 9.8 upon 4 into 3.14 whole square. So that is cancelled. So 9.8 divided by 3.14 square. Right? So that is also similar to the 9.8 something. So it's equal to 1 meter approximately. So the length of the pendulum is 1 meter. So A is numerical, maybe ask for the objective type question. Clear this? Again, here the numerical data is not given, only the wording are given. What is the length of a simple pendulum which ticks the second? Ticks the second, that means when it completes the half oscillation. At the time, one ticks is listen. Now again half, again what's happened? The one ticks. That means the 1 second is time taken to travel the distance from one extreme point to the other extreme point. So there is the 1 second, again 1 second. That means for one oscillation, total time is 2 seconds. Therefore, the periodic time of the simple pendulum which ticks second is t is equal to 2 seconds. And now using the equation of periodic time of simple pendulum, t is equal to 2 pi under root of L upon G, we can calculate the L is equal to 1 meter.